Now let's do a couple problems involving both of these. So a solution of glycerol, C3H8O, in 750 grams of water has a boiling point of 104.3 degrees Celsius at a pressure of 1 atmosphere. How many grams of glycerol are in the solution? Always start with your formula. This is a boiling point formula, a boiling point problem because it says boiling point. So I write my delta T equals KBM. Okay? Plug in what you know. What do I know? Well, the boiling point is 104.3 degrees Celsius. Well, that's great, but does that tell me the change? No. I know that water's normal boiling point is 100. The new boiling point is 104.3, so therefore my delta T must be 4.3. KB for water is 0.52, and I'm left with solving for molality. Now, does solving for molality help me? Sort of, because I know that the molality is equal to moles over kilograms of water. I have the mass of the water here, so I can find the kilograms of the water. If I have the molality, I can solve for moles, and once I have moles, I can solve for grams. So this will actually lead me down the right path eventually. So let me do my math real fast. So I have to pull out my handy dandy calculator. You gotta be able to see my calculations. So I take 4.3, always divide by the variable. I'm sorry, divide by the thing connected to the variable. So 4.3 divided by 0.52 is 8.27. Not important how many numbers I write down, as long as I use the full number from the calculator and don't round until I get to the final answer. So 8.27 is equal to moles over kilograms of water. It's got in grams, so I divide by 1,000 to give me 0.75 kilograms. Cross multiply and solve for moles. So I have my 8.27 times 0.750 is 6.202. Oops, moles. Now, because I'm dealing with molality, molality is moles of solute over kilograms of solvent. This is moles of my glycerol. So I'm just going to bring this number down here, 6.202 moles. Do my quick mole conversion. I don't know the weight of glycerol off the top of my head, so I'm going to add it up real fast. So I've got 3 times 12.01 plus 8.08 plus 16 is 60.11 grams times 6.2019 is 373 grams of C3H8O. So you can see a considerable amount of mass had to be added just to raise the temperature 4.3 degrees Celsius. Okay, let's try another. What is the boiling point? This is from the homework. I'm being a nice guy and helping you out with homework number 2. What is the boiling point of a solution composed of 15 grams of urea, OCNH22, in 0.5 kilograms of water? Again, it's a boiling point problem, so we write down our boiling point formula, and we're eventually going to have to use molality. So let's write down our molality formula. It asks me for the boiling point. So I don't have the boiling point, so I'm going to be solving for delta T. I know that KB is 0.52 because I'm dealing with water. I don't have the molality. I'm going to find the molality first because they give me the grams of my solute. I know that I'm dealing with 0.500 kilograms of water. So let me do a quick mole conversion. To figure out how many moles of urea I have. Put this right in the center for me. So let's find the mass of urea. It is 16 plus 12.01 plus 4 hydrogens plus 2 nitrogens is 28, 60.05 I'll do 15 divided by 60.05 is 0.250. 60.05, 0.250 moles. Again, it doesn't matter how many sig figs I keep in these steps as long as I keep the correct number of sig figs in the final answer. I'm doing this math right here. So take that number, divide by 0.5, and I get 0.4996. 4996 little m. Remember, units are important. So it comes over here, 996 goes into this formula, multiply it by 0.52, and I get 0.260, we'll call it, degrees Celsius. That is not my answer. That is only the change in temperature. So this is 100 plus 0.260 is equal to. Now this is where significant figures get a little iffy. Keep the significant figures here. Okay? And then just add it to the 100. So I need 3 significant figures, so I keep it at 0.260. So this becomes 100.260 degrees Celsius, and that is the boiling point of this solution. Okay, you need to keep those 3 digits plus. I know there's more than 3 sig figs, but it works out better this way so that you don't lose important information. Okay, last one. Let's talk about freezing point. If 52.5 grams of lithium fluoride is dissolved in 300 grams of water, what is the expected freezing point? Again, write down your formula. Hopefully you'll be able to solve this one without me. So you should pause the video and come back to this in a second when I'm done and check your work. Okay, they asked me for the freezing point, so I'm going to solve for delta T. I know the freezing point constant for water is 1.86. I'm going to need the molality from over here. So they tell me that there are 300 grams, which is 0.300 kilograms of water. I don't have the moles, but I do have the grams of lithium fluoride. So 52.5 grams, LIF. Do a little mole conversion. Lithium is 6.94, fluorine is 19, so that's 25.94 grams. That's math I can do in my head. So let me do my mole conversion real fast. 52.5 divided by 25.94 is 2.02. 2.02 moles. That goes up here in the mole conversion. Divided by 0.3 is 6.75. Little m. Units. Times 1.86 is 12.5 Celsius. Again, you're going to keep your sig figs here. This is the important part for sig figs. Okay? Water freezes at 0 degrees Celsius, and it's going down. So it's 0 minus 12.5 is equal to negative 12.5 degrees Celsius. Always remember, delta T is only the change. It's not the actual freezing point or boiling point. And that's how to do colligative property calculations.